Hello friends, so in this video we are going to have a discussion on how to flash OpenWRT onto the Raspberry Pi 3B Plus, that is our target device. So as a brief intro about the OpenWRT is a open source project for embedded devices that is based on Linux. So it's mainly used on the wireless routers. So we have a lot of devices into the world that works on OpenWRT because they have a fully writable file system and have a very small footprint of memory onto the embedded device that is actually needed. So we have a full control over to this wireless router through the CLI or through the web GUI, that is Lucy in this case. So if you don't know much about the OpenWRT, you can hit the link given in the description below. So let's start. What are all the steps we need to port? So the first thing we need to know about our host and the target device. So the host is the system on which we are cross compiling our OS for the target hardware. So here our target device is Raspberry Pi 3B Plus, and our target OS as it's OpenWRT. And what are the steps? So the steps for preparing the build environment of OpenWRT. So we have to first clone a repository from the GitHub. So it's all done on a host system, and then we need to enter into the directory, and then we need to update the package feeds into the OpenWRT, so that all the recent updates onto the packages will be available before building our OS. So the next we need to install our the software links to all the feeds. So the feeds here are the packages that is available onto the GitHub. And then after these commands, once we download our build system, then we need to have make menu config if we want to have some changes onto our the target OS regarding the kernel modules, regarding the list of packages, and various other configurations that are available when we hit the make menu config. And if we need some changes onto the kernel part, then we can use make linux menu config command onto our build system to configure our OS for the target hardware. And once we done with this make menu config, we will have a .config files that contains all the configuration that we have done. And then the next step is to just make. Okay, we just make it, and by taking the number of processors onto your the host system, and then we need to print some logs while running. So these one, two, three, four, five, six steps are needed onto the host system to build the image for our target hardware. So once these all steps are completed successfully, then we will have a image of our OS that we need to flash onto the Raspberry Pi, that is our target hardware. So here we are creating our OS that runs on the the device that is external to that. Okay, so by doing this we will have our build environment ready. We have our U-boot, we have our the cross compiling tool chain and the list of packages that is compiled with our image that is created with these steps. And the next, so the before that we need to check for the build dependencies also. Before running this make, we need to have these list of packages that is available, and we just need to have if you have a Ubuntu system or a Linux system, then you must have to install these all packages before compiling for the build environment, right? So the next step is to flash our OpenWRT image to the SD card. So we just need to insert the SD card and have check for the device. So we'll have to check for the device which is up in /dev, and you will get a name STB or SDC, whatever. So you need to plug in and plug out and check for this device. So you should be very cautious about DD command, which we will be firing for flashing this image onto the SD card, because if we have other USB devices that are attached, so it may be misconfigured. So take extra precaution while using the DD command. So this DD command will flash our image, that is a squash fs for the image, and this we need to flash onto the the USB device that contains the memory card. And once we do it, we just have to give a sync command, so that all the data is been synced with that memory card, and all the partitions that are also required that are also created by this. So you just have to do this. And then the next thing is you need to insert the SD card onto the target device, and you just have to power up your device to see your OS is up and running. Then for the first time installation, you need to access the serial port of your Raspberry Pi, right? So for that you need one device here. So here we have a PL2303 device, and this device is USB TTL that converts the serial input onto the USB. And we also need to enable this driver before building in this make menu config. We will see in the practical form how it can be done. So after this, you need to select this kernel module for your PL2303, and once you do that, your USB to serial device is up, and you can access the logs onto your Raspberry Pi. Okay, so if you need to access your Raspberry Pi from the LAN network by the Ethernet cable connected to your Raspberry Pi, then you need to have this open SSH server package, and you need to enable it at the time of building your OS. And then you need to change the etc config network file for DHCP to take the IP through DHCP. By default this IP is statically assigned, and after that you just need to have SSH onto your root device, and at the rate with the IP of that device, whichever you get. Okay, so now we need to see how to connect our USB TTL to our Raspberry Pi. So this is a GPIO pinout of the Raspberry Pi 3B plus. So we have 40 GPIOs pin and the 3.3 volt power. This first pin of the GPIO of your Raspberry Pi, you need to connect to the USB TTL PL2303. Then you have ground. Then here is a trick. Here you have TX and RX of the Raspberry Pi, and you need to connect the RX of the USB TTL to the TX of Raspberry Pi, and the RX D pin, that is pin number 15, to the TX of the USB TTL. So once you do that, your serial output is ready and you can access. So let's now go to the terminal to see how it can be done physically. So here we are on the terminal. So let's check for the step 1 that we have discussed earlier. We need to download the build system, and if we have check for the remote branch, then we have to show origin. Then we'll see that I have taken the master branch from this URL that we have discussed. So you can take any other branch, whatever is required for your operation. So the first step that we do is make menu config to config for our build system. So when we hit this make menu config screen for configuration, so there are three main things that we have to select here. First is the target system. So we have Broadcom BCM2710 chipset in the Raspberry Pi 3B plus. So we have to select for this the SoC, and next we have to check for the board. So board is 2710 board. Okay, so and the third one is the target profile on which we are porting, and this is Raspberry Pi, and they have taken all the versions here. So these three things, and if we want to add something more, some more packages, or the utilities or libraries, or you have some kernel stuff, so you can select it from these devices. So that we have discussed. So there are various kernel modules that we can select to make our the image customizable. Okay, so if you don't want to do such tedious work to select each and every package, so there is one solution. So when we do make menu config, we get a .config file. Okay, so this is all the configuration that we can do from make menu config. So I have a the def config for this Raspberry Pi 3B plus, that is on my GitHub repository. So I will put the link of this repository so that you can download this config file. So there are a lot of stuff I have enabled I2C and SPI. So what you have to do, you just have to copy this config file and you have to paste it in this config file, right? So once you do that, your that configuration is set up in your OpenWRT build environment, and you can create an image out of that. So okay, so as we are done with our config part, now we want to build this OpenWRT. So we'll use make -j, then we have n proc, then we have v is equal to s for verbose, and when we hit our build system will start building, and it will take approximate 1 to 2 hours to build this setup. So just wait. So we are done with our build, and let's check where our image is created. So let's go to bin, then we have targets, then we have the SOC, and then if we see, then we have a squash fs image of our OpenWRT. So this image we will be porting onto the memory card that we will insert in our Raspberry Pi. So let's if you see here, the image is just 19 MB, right? So let's uncompress it. We have, okay, so we have our image now. Now the next step is to flash this image onto our memory card that will insert in our Raspberry Pi. So here is the memory card, and we have 32-bit and class 10 memory card here. And now we'll check for the dev interfaces. So we have then we have dev st, and we have only sta. So now I am going to insert my card reader to the laptop. So I have inserted now. So now we see there is one more dev interface that is for the memory card. Now we are going to flash our image onto the memory card. So we have a dd command. Okay, so we have the dd command, and we have the image. So let's check if it is the same image. Yes, it's the same image. So if we have if the image, then we have our dev interface for the memory card, and then we are going to hit enter here. So now take the password. Now it's been flashed. Now we have to go for sync command. So you'll see it will take some time to write all the data onto our memory card. So it's done now. Okay, so now we want to eject this memory card. So just go here and eject it. Now we are going to put this memory card into the Raspberry Pi. So I'm putting it in our Raspberry Pi. So just put it up, and now we want to check for the serial logs. So I have this PL2303 module, as you can see here. So they have 4 pins. Here we have 3.3 volts, TX, RX, and ground. These 4 pins are connected to the Raspberry Pi, as we have already mentioned. So I am going to connect this to my laptop, and I am going to access it with the serial port. So I just connect it. Now I'm going to have a utility that is picocom, and I am going to access my interface for the PL2303, and just hit enter here. So our logs are coming from our Raspberry Pi. So it's been booting up. Just wait for a few seconds. So now we are in the terminal of OpenWRT, and now the first thing we need to check here. Okay, so you are getting some the logs from IPv6. To disable this log as it is continuous in some case, so we have some commands to disable these logs, because we don't need the IPv6 traffic from our interface. So just copy this and we'll go for vim. Then we have etc syscontrol.conf, and I've already put it here. I just have to reload the syscontrol with this, and now you'll see your messages will gone. Now the first step, now here I have to check the interface. So I have Ethernet connected to my Raspberry Pi to my home LAN network. So just go to vim etc config network, and when we open this, we need to see this thing. So these two commands, this is our interface, LAN interface, and we are giving the DHCP. So if you are running it for the first time, you may get the static interface here. So you have to check this before proceeding, as we want to access our Raspberry Pi from SSH. So once you do these settings, then we have to reinitialize our DHCP. So we'll get the IP. So we'll check if config, we'll get this IP here also. So in spite of using the serial port, we can also use the SSH. So let's exit. So now I want to access my Raspberry Pi through the the IP interface from my LAN. So I just disconnect my serial port now. Okay, now I have to go for SSH root @ the IP 168.29.2, and when we hit that, we are now connected through SSH. Goodbye, take care.